In this paper, we first reorient the DDM baseline to be more conducive to self-supervised learning. We adapt the DDM baseline and introduce a new model, DIT-L, which shows a linear probe accuracy of 57.5% using its 1/2 L encoder. The generation quality of the DIT-L model, measured by the Frechet inception distance, FID 50K, is reported as 11.6. Next, we deconstruct the tokenizer, simplifying the VAE tokenizer step by step. We compare 4 variants of autoencoders as tokenizers: patch-wise PCA, convolutional VAE, convolutional AE, and patch-wise A. Our findings indicate that all patch-based tokenizers perform similarly and consistently outperform the convolutional VAE variant. Interestingly, we find that the KL regularization term is unnecessary, as both the A and PCA variants work well. Even the PCA tokenizer performs well without requiring gradient-based training. We then move towards classical DAEs, attempting to remove every aspect that remains between the current PCA-based DDM and classical DAE practice. Our results show that using a single-level noise achieves a decent accuracy of 61.5%, with a 3% degradation. Compared to the multi-level noise counterpart, we conclude that multi-level noise is useful, but not an enabling factor, and the representation capability of DDM is mainly gained through the denoising-driven process. In our analysis and comparison of results, we compare the LDAE method with previous baselines, including MoCo v3, contrastive learning, and masking-based. The LDAE method performs decently compared to MAE, showing a degradation of 1.4%. VIT-BIT, VIT-VIT 8%, VIT-L. However, autoencoder-based methods, MAE and LDAE, still fall short compared to contrastive learning methods under this protocol, especially with smaller models. Overall, our deconstruction trajectory aims to gain a better understanding of DDMs and push them towards classical DAEs for self-supervised learning. We achieve improvements in adapting DDM for self-supervised learning, simplifying the tokenizer, and moving towards classical DAEs. These specific improvements and modifications are highlighted in the results and comparisons provided in our study.